I'm Anil Kumar. Welcome to my series on inverse trigonometric functions. In this video, we'll talk about inverse of cosine functions, inverse of sine functions. We'll also look into these properties that sine inverse of sine x is equal to x only if x is between minus pi by 2 and pi by 2. Sine of sine inverse x is also equal to x if x is between minus 1 and 1. And similar properties also hold good for cosine, provided x is between 0 to pi. Okay, we'll take a few examples like shown here to find the value of each using these properties and the concept. Now, before we begin, we should understand that inverse of a function is a function only if we have 1 to 1 function, right? So we should have 1 to 1 function for inverse to be a function. Correct? So you remember horizontal line test, that's what we are referring to. But if you look into these functions, which are sine and cosine functions, if I sketch it, then the cosine function is kind of like this, right? And the sine function is kind of like this. Now both these functions fail vertical line test, a horizontal line test. So if I draw a horizontal line, it crosses many points, and therefore we cannot have inverse of these functions. So that really means that for working on inverse, we need to restrict domain. So whenever we are talking about inverse of trigonometric functions, we'll work with restricted domain. That is kind of important, right? So keep in mind that restricting domain is critical. So for the cosine function, you can see I could restrict the domain from 0 to pi, correct? And for sine function, let me extend this. So for sine function, we are going to restrict the domain from minus pi by 2 to pi by 2. This portion. Now if you look into only this portion, then it's one-on-one function, right? So here it is that portion, which is one-on-one. So that gives you an idea of why we're talking about these values. Is that clear? Now with that, let's look into the details of finding inverse of these functions, and then we'll take up examples as shown to solve some questions. Try to understand how to find inverse of cosine function. So as I was discussing with you, let's draw the cosine function. It could be kind of like this. So at 0, the value is 1. And at 2 pi, it is again 1. But you see that it fails horizontal line test, right? So if I draw a horizontal line, it crosses the graph of the function at more than one point. But you will notice that if I restrict the domain from 0 to pi, in that case, within this domain of 0 to pi, it passes horizontal line, correct? So what we can say here is that, let's say this is x and this is y. In that case, cos x is 1 to 1 if the value of x is restricted between some interval. So normally we take it from 0 to pi. So once we say that this function y equals to cos x is 1 to 1, then we could always write this as cos inverse of y equals to x. And that is how we get our inverse function. Do you get it? So cos inverse of y is x. Now you could see that the inverse of this function, now for cos x, when we restrict the domain from 0 to pi, we know that the y value is from -1 to +1, correct? Now when you write the inverse of the function, which is cos inverse x, right? So we could now write this inverse function as, you could write in this way, but the inverse of this function could be written as y equals to cos inverse x. Now in this case, what is the domain? Now in this case, domain and range will flip. So the domain here is between plus and -1, and the range is between 0 to pi. So that is how the inverse of cosine function is related. Correct? Now, if I have to sketch both these functions on the same scale, how do we do it? Now, let me, because I didn't leave some space here, let me redraw these two portions. So we'll redraw this function and sketch the domain and range of the cosine function. Now remember, the value of pi is 3.14, right? So we know that pi is equals to 3.14. So when I say that the range is between 0 to pi, in that case we have to we'll use the value 3.14. okay, now let's say the cosine function which we're talking about is kind of like this. Okay, so that is the cosine function, correct, where these values are 1 and this is -1, correct? So that is the cosine function from 0 to pi. Now to get the inverse of this function, what we could do is we could also reflect it on the line y equals to x, correct? Now this point which is pi -1, when you flip it, it becomes -1 pi. So at -1 you get pi, which is almost 3 times, correct? So you get this point here. This point comes here, which is -1 pi for the inverse function, correct? And the point here, which is 0, 1, so this is 0, 1, it will switch to 1, 0. You get an idea. It will switch to 1, 0 somewhere here, right? So this is 1. So that is how the function is going to be. Now, the value where it is going to be 0 is pi by 2. We know cos of pi by 2 is 0, right? We know this value here is pi by 2, correct? So cos of pi by 2 is 0. So at 0, it will be pi by 2. That means half of 3.15, somewhere here, right? So this value will be pi by 2. Correct? So let me write pi by 2 here. Kind of important point to consider. And if I sketch this graph, it is going to look like this. So there is an invariant point where both values are equal, correct? So that is at, as shown here, correct? So that is how you get inverse function. So we have inverse function in blue. So this inverse function is shown in blue. So let me write this as y equals to cos inverse x. It is not 1 over cos x, cos inverse x. And the function here is y equals to cos x. Do you see that? So from the inverse, it is very clear that the domain of this function is from -1, this is -1, to 1, and the range is from 0 to pi. Is that clear? So that is how you have to treat cosine inverse function. So I hope that step is absolutely clear. Now if you have a question, let's take some question on cosine function here. So if I say that cos inverse x is equal to square root 3 over 2. See, the x values between -1 and 1, we need to find, cos inverse of square root 3 over 2 is what we need to find. So what is that equal to? Say y equals to cos inverse of square root 3 over 2. So for that, you could actually rewrite and find it out. What is y value equals to? So you can say cos y is square root 3 over 2 using special triangle, which is, let me sketch here. Okay, so this is square root 3, 2. Cosine, it is pi by 6, correct? So we get y equals to pi by 6, correct? So that is how you could actually solve a question based on inverse of a function. You get an idea, right? Now if I take a negative value, for example, so if I say y equals to cos inverse of, let's say, minus 1 over square root 2. In that case, what is y equals to? You could write this as, you're looking for cos y equals to minus 1 over square root 2. And in the domain, which is from 0 to pi, the value of y should be equal to 3 pi by 4. You get an idea, right? So that is how you could actually find the solution of functions, inverse functions, with the help of what we've learned just now, correct? Now let's talk about inverse of sine function based on similar strategy. Now let us try to understand how to find inverse of sine function. So this time I'll leave some margin on the top so that we could sketch it properly, right? So we have sine function as, let's sketch this function. So we'll start from here. As I was saying, we need to restrict the domain of sine function to make it 1 to 1. So the restriction of the domain is done by taking the values of x between minus pi by 2 and plus pi by 2. Correct? So at minus pi by 2, the value is minus 1, and at plus pi by 2, it is plus 1. So within this domain, sine of x, y equals to sine of x, has domain which is x is between plus and minus pi by 2, right? And the range is that y is between plus and minus 1. Now, since it is one-to-one function, correct, it passes the horizontal line function, horizontal line test, so it is one-to-one function, right? So we can find the inverse, and inverse is going to be a function. So the inverse of this function could be calculated by swapping, right? So when you swap, you get x equals to sine of y, or you can write y equals to sine inverse x, correct? So you get the inverse of this function. So once you get the inverse, now you could actually swap the points also. So 0, 0 remains here. So that point is common to both. The point here is pi by 2, 1. So it flips to 1 pi by 2, correct? So let us say 1 is kind of here, and it flips to 1 pi by 2. Let's say that is pi by 2 for us. Okay, so in that case, it is going to be a point here for the inverse. This point will move to that. 0 remains at 0, and the point which is minus pi by 2 minus 1 will become, this is 1 for us, this will be now minus 1. Let's say this is minus 1. So it will be minus 1 minus pi by 2, which is going to be, so let's say this is minus pi by 2. So minus 1 minus pi by 2, correct? So that becomes the inverse of this function. Now we can sketch this particular function passing through the origin. So this function here is the inverse function. So that is sine inverse x, y equals to. Is it okay? Original function is here, which is sine x. You get an idea, right? So that is how you get the inverse of the function. But remember, whenever you do this inverse function, now the domain of this inverse function is between, as you can see from here, from minus 1 to 1, correct? So it is from minus 1 to 1, and the range of inverse of this function is between minus pi by 2 to plus pi by 2. So that becomes the range, correct? Pi by 2. So I hope these steps are absolutely clear, right? Now, once you know this, we could solve many questions related to inverse function. Let me take some for you. Let's say we need to find sine inverse of minus 1. Let's say, so y equals to sine inverse of minus 1. So how are you going to do it? Now, in the inverse function, we know sine inverse of minus 1 will be minus pi by 2, correct? Or you could write this as sine y equals to minus 1, and that gives you y equals to minus pi by 2. So you can read from this graph to get the value. Is that clear? Now if I take another example, this is one example. Let's take one more example. Let's say we want to do sine inverse of square root 3 over 2. Right? So in that case, we are looking for sine y equals to square root 3 over 2. Getting back to our special triangles, square root 3 over 2 means this angle, which is pi by 3. So we get y equals to pi by 3, correct? So it is within the given domain. Perfect. That is how you're going to solve such questions. So I hope it makes sense. We'll take up more examples as we move forward, but you can try these. So let's say sine inverse of minus square root 2 over 2. Right, so find y. So you could try this as an example. But I hope the concept is clear. To find inverse of a sine function, we have to restrict the domain to minus pi by 2 to pi by 2. Okay, let's continue. Let us again look into our strategy of answering questions based on inverse trigonometric functions. The question here is, find the value of each of the following. Sine inverse of minus 1, sine inverse of 1 over square root 2, cos inverse of minus square root 3 over 2, and cos inverse of 0. Now remember one thing, we are trying to find what is y equals to, right? So that is what we're trying to figure out. Okay. Now, whenever you're trying to find this value of y, as you remember, for the inverse cosine function, the value will be between minus pi by 2 to plus pi by 2, correct? So for the inverse function, we are looking for a value which is between minus pi by 2 to plus pi by 2. So that's the key when we are trying to solve the inverse function problems, right? So here for sine, for these two, we are actually looking for the value of y, which is between minus pi by 2 and plus pi by 2. Correct? So based on this, we can rewrite these equations as sine y equals to minus 1 and sine y equals to 1 over square root 2. Now looking into our triangle, let's say quadrant. So first we'll look into the quadrant. Minus pi by 2 and plus pi by 2, that means we are looking into solution somewhere in this portion. Do not write answers in quadrant 2. That's what I'm trying to show you here. Okay. Now, so when we say minus 1, in that case, the value is minus pi by 2, correct? So that is pi by 2 for you, and this is minus pi by 2. And that's the domain, right? So from here, you get solution of the first as y equals to minus pi by 2. This is positive value of 1 over square root 2, which you know is for pi by 4. And that gives you the answer in quadrant 1. So here y equals to pi by 4. So if you visualize, it becomes much simpler, correct? Now similar approach I'm going to take for the cosine function, where we know that the y value is between 0 to pi, correct? So getting back to the quadrants, we are actually looking for the solution which is within this, correct? So that is what we're trying to say. It is between 0 to pi, between this. This is the y value we are looking for, correct? So if you rearrange, we say cos y is equal to minus square root 3 over 2. And the other one is cos y equals to 0. Now when is cos 0? Cos 0 is right there, correct? So we get y equals to pi by 2. And when is cos negative 3 pi by 2? So you could take help of your special triangle. Let me sketch one here again for you. Square root 3 means we are looking for this side and 2. So that is the angle for cos, which is pi by 6. Correct? So pi by 6 is the acute angle. Correct? So the solution is like this, where this angle is pi by 6, or the angle which we are considering between 0 to pi is 5 pi by 6. So the answer here is y equals to 5 pi by 6. Does make sense to you? So the inverse questions could be answered like I'm showing you. I showed you all 4 solutions so quickly. So that is how you should be doing it. So we'll take a few more examples which will be involving both sine x and their inverse or cos x and their inverse. I hope you are enjoying this journey and understanding the functions, the inverse of these trigonometric functions. Now to end this video, let us try to understand that when x is between minus pi by 2 to plus pi by 2, in that case only sine inverse of sine x is x and sine of sine inverse x is also x, correct? So the important condition which you learned is that the values should be within the interval shown, correct? So whenever we are talking about sine function, remember sine inverse function, we're talking about somewhere here. These are the x values, plus minus 1 or whatever you may say, right? Okay. But when we talk about the cosine function, in that case, we are looking into a domain which is between 0 to pi. Right? So if that is the case, in that case only we have one-to-one function. And if that is the case, then we know that f inverse of f of x is equal to x, and also f of f inverse x is also equal to x. This is true only for one-on-one function. Is that okay? So let me give you an example here so that you could see whether the answer will be x or not, correct? So let's say the function is sine inverse sine pi by 3, correct? So if I write sine inverse sine pi by 3, the answer should be, since pi by 3, that value is within your domain between plus minus pi by 2, right? It is here. And therefore, this answer will be pi by 3. Is that okay? However, if I write sine inverse of sine, now if I write this as 2 pi by 3, in that case, it is not equal to 2 pi by 3. Are you getting my point? Since this is not in the interval minus pi by 2 to pi by 3. Okay, so that is kind of critical to understand. Okay, so you could make some mistakes. So this answer is actually also equal to pi by 3. Anyway, we'll get to this later. Similarly, let me give you another example for cosine function. If I write cos of, let's say, we say cos of cos inverse, let's say cos of cos inverse, let's say 0. What do you expect? You expect 0 as your answer, correct? Because this 0 is within minus 1 and 1, correct? So it works, correct? Similarly, if I give you cos inverse of, let us say cos of minus 2 pi by 3. Now if I give you cos inverse of cos of minus 2 pi by 3, then what is your answer? This is what you need to figure out. Is it equal to minus 2 pi by 3? So what you have to do here is see this portion. Cos of x is between 0 to pi, not minus 2 pi by 3. So for sure, it is not equal to minus 2 pi by 3. Do you see that? Since it is not within this interval. You're getting my point, right? So that's what we're trying to say. So this holds good only if x is within the given domain. Otherwise, this value is going to be different, right? So find the answer. So let this be a question for you. Is it okay? We'll look into these examples further, but I hope we have got the gist of inverse trigonometric functions. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.